In this video, we will learn how to find out the maximum point and minimum point of a function. The question is, the function y is equal to 100 upon x plus 4x has options are being given. We need to find out the correct option. This is a multi-select option question. Okay, so there can be more than one correct options. Okay, so we have the function y is equal to 100 upon x plus 4x. Okay, now first thing is first, what we do to find out maximum point or minimum point, we take the first derivative. Okay, so let's take the derivative of this function, that is dy upon dx, and we set it equal to 0 because first derivative gives us the slope of the function where the slope is equal to 0. Now derivative of 100 upon x, its derivative is, it becomes negative 100 upon x square. Now if you are wondering why, how did we get this, so let us see here. If y is equal to 100 upon x, this can be written like this: 100 times, if I transpose this denominator to numerator, exponent sign will change. Then dy upon dx means we differentiate it with respect to x. Exponent becomes coefficient, so we have negative 1 times 100, and exponent is subtracted by 1, so we have negative 1, negative 1. Okay, minus 1 here, so it becomes minus 100 x raised power negative 2, which is equal to negative 100 upon x square. Transposing this to denominator, exponent sign changes. Okay, power function rule, as we know, it is x raised power n is equal to n times x raised power n minus 1. Okay, the derivative of this is this function. Okay, this is how do we get this, plus the derivative of x is 1, so we are left with 4, and we set it equal to 0. What does this tell us? So if I draw the graph, if I have x and y here, so I'm not sure what will be the graph of this, so let us suppose we have this kind of function. Okay, so first derivative shows us the point is where slope is equal to 0. Okay, so if I take this rough sketch, so at this point slope is 0, slope is 0, slope is 0. So to test the slope equal to 0, we set first derivative equal to 0. Okay, now let us solve for x here. Okay, can we rewrite it like this? Transpose this negative term to RHS, so it will become positive 100 upon x square is equal to 4. Or we can rewrite it like this: x square times 4 is equal to 100, or x square is equal to 100. Transpose this, it gets divided, which is equal to 25, or x square is equal to 25, or x will be equal to plus minus under root 25, or x will be equal to plus 5, or x is equal to negative 5. So we got 2 points where slope is equal to 0. Okay, but to check whether which among these 2 points is maximum point or minimum point, for that we need to check the second derivative test. Okay, so we take the, so this was our first order condition. So first order condition shows us the points where slope is equal to 0, slope is equal to 0. Okay, this is not the sketch of this function. Okay, so first order condition simply tells us the point is where dx is equal to 0. Okay, now to check out this, to check the second order condition, okay, for that we take the second derivative. Since this is the first derivative, now let's take the second derivative, d square y upon dx square. So we need to take the derivative of this function with respect to x again to find out the second derivative. Now we have this function. Okay, since dy upon dx is equal to minus 100 upon x square plus 4, I can rewrite it like this again: minus 100, transpose this here, it becomes x raised power negative 2 plus 4. Okay, so this is dy upon dx. Now d square y upon dx square means the derivative of this function again with respect to x. Again the exponent becomes coefficient, so we have negative 2 times negative 100, and exponent is subtracted by 1, so it becomes negative 3, and the derivative of a constant is 0. So we get minus, sorry, negative into negative is positive, we get 200 x raised power minus 3, and it can be written as 200 upon x cube. Transposing numerator to denominator, exponent sign changes. So we got 200 upon x cube as the second derivative. Now we need to check the second derivative at the critical points that we got, the points where x is equal to 5, x is equal to negative 5. These points are the points where slope is equal to 0. Okay, now we need to find out which among these is minimum point or maximum point. So what we do, we plug. So we have d square y upon dx square, and we put first x is equal to 5 in this equation, in this function rather. So we get here 200 upon x cube minus, so here we have 5, so 5 into 5 into 5 is, so we have 5 cube, which is equal to 200 upon 125. Obviously this number will be greater than 0. If the second derivative comes out to be greater than 0, what does this mean? It means we have a convex function. Okay, and if it is convex, that implies this point x is equal to 5 is a minimum point. Okay, so this point shows us the minimum. Now let's take the second point and evaluate the second point in the second derivative. X is equal to negative 5. So we have 200 upon negative 5 cube. It will be equal to 200 upon 5 into 5 is 5 into 5 into 5 is negative 125. Obviously this number will be less than 0. So if it is less than 0, so we get a concave curve. If we have concave, so this point shows us the maximum point. Okay, on graph, what is meant by this? Now when x is equal to negative 5, okay, this is not this was only a rough. So when x is equal to negative 5, so let me try to show it graphically. Okay, I am really sorry I cannot picture the graph perfectly here. So since x is equal to negative 5, our function should look like this, I guess, then this, like this. So at this point x is equal to negative 5, the function has maximum. Okay, so this point is maximum since slope is equal to 0, and at this point when x is equal to 5, it is a minimum point, this is a maximum point. Okay, so when x is equal to 5, we have minimum point. When x is equal to negative 5, we have maximum point. So see the correction, see the options. So a minimum point at x is equal to 5, yes, sorry, a maximum point at x is equal to 5, no, maximum occurs at negative 5, so this is incorrect. A minimum point at x is equal to 5, yes, x is equal to 5, we get minimum, this is true. A maximum point at x is equal to negative 5, yes, that is true. So then a minimum point at x is equal to negative 5, no. So these two options should be correct, B and C. I hope I make myself clear in this video. Thank you.